Numero nueve. Number 9. Here we go. So we have a e that we got to integrate. We have a definite integral. It's a definite integral because we have a 0 and a 1 right there, which means we do not have a plus c in our answer. Okay, so how do we do this? Now, there's different ways to do this. If you're really good at integrating e's, then you wouldn't have to use u-substitution. I'm going to use u-substitution because I feel like it is easier for a noob to do if you use u-substitution. That is a function inside of the function base e. And so I'm going to say u equals negative 4x. du, which is the derivative, you can write du dx if you want. The derivative of negative 4x is negative 4. And then you multiply both sides by dx, so you have du equals negative 4 dx. Now, the way I like to do u substitution is I like whatever I'm subbing out to look exactly like what I see in the integrand. So I'm going to multiply both sides by negative 1/4, so that negative 4 can go away, and you have a positive 1 dx. On the other side, I have a negative 1/4 du. And so this guy and this guy are the guys I'm going to be subbing into my integral to make it look prettier. Okay, so I'm going to not write my lower and upper bounds because those are x values, and now I have u's. Okay, when I take out the dx, I have the scalar and the du, so I'm going to put the du right here and the scalar on the outside, waiting to multiply to my result of the integral. Now, what is the integral of e to the u? E to the u. Isn't it beautiful? So I have negative 1/4 times e to the u. And because we have a definite integral, I'm going to put my vertical line right here, which is where I would put my upper bound and my lower bound. But here's where we run into a speed bump. Okay, you cannot use the 1 and the 0 for what we have currently because it's a u. We got to put u numbers right here. So you could do it this way. You could take the x numbers and change them into u's by plugging them into this cute little equation right here. And so if I were to plug 1 into this guy, it'd be negative 4 times 1. And so the 1 would become a negative 4. And then I would plug 0 into this diggity dude, and I had negative 4 times 0, which is 0. So now these are u values, which I can easily plug into the u. Now pause. What's the other way to do it, Mr. Patey? The other way to do it is to take this and sub out the u. You can go 1/4 e to the u, but instead of u, I'm going to write what u is. What is u? U is negative 4x, and then I can use the 1 and the 0 because they're x's and plug them in that way. You could do whichever way you like. This one's my favorite way because I usually can write less, because this stuff I can usually do in my head, and then I could write what the u values are, and then I can finish my integration using the fundamental theorem of calculus. So I plug in negative 4 first, subtract, and then I'm going to plug in 0 and see what my results are. So this is going to be positive. E to the 0 is 1, and so my result is negative 1/4 with the e on the bottom, so it has a positive exponent, plus 1/4, because it's times 1/4. And that's my answer. Shebang-a-dang. All right, let's see. Let's see what we got here. Oh, look at that. Look at that. The e to the negative 4th. That's kind of weird, but that is our answer right there. See, we got the negative, and we could put this guy on the bottom to make it look exactly like ours. D is our answer.